Good afternoon, everyone. My talk is about concurrency. So this is a RubyConf and Ruby and Elixir conference. So maybe people want to utilize some many core, much core. So maybe you use Elixir, but next Ruby 3 we can use parallel execution on. We can write parallel execution programs on Ruby. So I'm working on this next Ruby 3's feature. So today I want to show you the current status of this my work. So today I will talk about several topics. So at first, why the thread programming is difficult, and the next one is what is the next new concurrency abstraction for the Ruby 3. We named it Guild. So this is a code name, and so just now I'm working on that, and so I will introduce some current situation status about Guild feature. So let me introduce myself. I was a faculty and moved to Helku, and just now I'm a member of ClickPart. But all of company, I'm working on Ruby's development, so I don't change my job, but I change my companies. So I'm also a virtual machine or current garbage collector or something like such a lower level developer. So my next target is how to execute Ruby's program in concurrent or parallel. And I'm one of the translator of programming Elixir, so to Japanese. So maybe I know something about the Elixir, and I can import Elixir feature to Ruby. So this is some interest because Ruby, so Elixir is inspired by Ruby, and just now we inspired by from Elixir. So it is a good cycle, I think. So recently, so this the beginning of this year, I'm working for the several performance tuning for the about pro core or something like that. So Ruby 2.6 released at next Christmas. Well, it has some faster pro core or something like that. So back to my main topic. So at the Ruby Kaigi 2016, I proposed the new concurrency model for Ruby 3. At this time, so I proposed the new concurrency model. So the motivation is productivity and performance. So for productivity, maybe you know that the thread making a thread program is very, very difficult and very, very difficult to debug the program problems. So I want to introduce some concurrent entity, concurrent abstraction. It is easy to write, and also I want to introduce some parallel execution feature to Ruby, so we can utilize many core or multi-core with Ruby. So unfortunately, MathRuby MRI MathRuby interpreter can't run threads in multi-cores, so we can't run program on parallel. So I want to overcome this limitation. So such background, I propose a new concurrency abstraction Ruby Guild. So the key idea is do not share mutable object usually easily, And there are no data race, no race conditions, and something like such a thread difficulty of thread programming. So at last, I want to replace the thread with guild. So I want to introduce why thread programming is difficult. So there are many reasons why the thread programming is difficult. So one is data race or race condition, or deadlock, live lock, difficulty of debugging or something like that. So this part, the first part is difficult to make correct thread safe programs. And also, it is difficult to make faster thread programs. We need to introduce some mutex or some synchronization features, but if we introduce many synchronization logs or something like that, it will slow down the program. So it is very difficult to tune the programs. So maybe, but the most important thing, most difficult thing, I think, is this data race or race condition problem. So I want to introduce why it is difficult. So if we make thread programs, we can share any object each thread between threads. So if we write these programs, this program, so make two programs, two objects bind to the local variable or global variable. So it is stored at this space, and thread 1 and thread 2 can share each other. So this is the background. So please assume this is a speaker object. So we have there are two attributes, name and gender. So the name is Koichi and male, so gender is male. So let's assume that I want to change this name and gender. And please assume that thread A and thread B share one object. So to replace the name and gender, so we change the name to Yuki and gender to female. And we can see the complete replaced object. So there are lucky case, but there is an unlucky case. So if we change the name by thread A, and this timing, thread B sees this speaker object, then the speaker object shows Yuki is male. So Yuki is my wife, and Yuki is female, so it is incorrect data. So critical problem. So to avoid such a critical issue in thread problems, so we need to introduce some synchronization features, like mutex or queue, something like that. So using a mutex lock, before change this object, we need to lock by A and change the name. And if we want to see this object from thread B, we can't acquire lock by B, so it is already locked. So we can change this. We can complete this the replacement. So this is a thread programs. We need to lock, or we need to introduce such a synchronization for every shared objects. So it means that we need to track all of mutable shared objects. So it is easy if the program is small. So there are several lines, so we can see, oh, it is shared object. But if you are using some framework like Rails, or if you use some gems, you don't know about that, you don't know about details, then you need to track everything there. So everything such a framework or James or library is using. So I think that such a tracking mutable shared objects is very difficult thing. So it means that we need to check the full source code includes libraries or gems or frameworks, or believe the documents for such a as a source code. So this is why the thread program is difficult, and the goal of Ruby 3 concurrency is so without such a difficulties, I want to make a correct thread safe concurrent program. So by restricting the sharing mutable object between threads, so to achieve this goal, we need to introduce object isolation mechanism for it and support parallel programs. So the next goal is support parallel programs. So nowadays we have so many core, multi-core machines. So at least this machine, this laptop has 4 cores, and so the parallel execution is so very important nowadays. So we need to utilize them then. And the last goal is keep compatibility with Ruby 2. So if we change the the specification from Ruby 2, and if we release Ruby 3 with some huge incompatibility, so nobody uses Ruby 3 like Python 3. So the compatibility is very important. So I don't say that the Python 3 is not used. So I know that the Python 3 is very well used. So use broadly. But I want to reduce the how to say, so compatibility gap. So the key idea is so this slide shows the key idea. The problem is multi-thread programming is too easy to share the mutable objects. So the key idea is to restrict sharing the mutable data. So mutable object is the problem. The very easy to approach is prohibit the mutable objects. So if we have immutable data, only immutable data, it will be solved. But so like Elixir or our language, everything is immutable, so there are no problem to use them by many processes or something like that. But it introduces a huge incompatibility. So maybe if you profit some kind of assignment or something like that, when maybe nobody uses Ruby 3, so we need to think another solution. So another option is copy everything. So if we want to share the object or object information, then if we copy everything, there are no sharing, no mutable sharing. So it is like a shell script. So we can send some data to another process, and each process is isolated. So there are no sharing. But it is difficult. So there are no. If we have no sharing data, it is difficult to program some kind of programs. And some case. So the object or some data is very big, then the transforming from process 1 to process 2 will have some overhead. So our solution is sharing only shareable object. So it means that we design it is a shareable or it is not shareable object, and so it's like that. So we define this object is no normal mutable object. So normal mutable object is not shareable. So we can't share these objects. But if it is a shareable object, we can share. So this approach is very nice because there are no mutable object sharing and easy to share shareable object and no compatibility issues. So if we use only one concurrent entity when there are no compatibility problem between Ruby 2. So this design named, so we working on this design named Guild. So after that, I want to introduce the current status of Guild. Guild. So these figures shows what's the guild and what's the thread and what's the fiber. So guild is one of so guild has at least one thread and thread has at least one fiber, and we can make several guilds, several threads, several fibers, and like that. And threads belong to different guilds can run in parallel. So we have a giant lock to prohibit thread programs run in parallel. But with guilds, we can run what? We can run we can run this T1 or T2 in concurrent, but it is not run in parallel. But T1 can run T1, T3 can run in parallel. So using guilds, so this code is very simple example to make a guild. So on this code, we made G1 and G2 guilds, and run expression 1 and run expression 2 respectively run in parallel. So at last, so these this code runs 3 guilds and 3 threads. So includes the main thread. So this is a very simple example. And we need to define what is a shareable object and what is a non-shareable object. So the basic idea is observing the concurrent programs, the most of objects are not shared objects. So it means that most of objects are thread local. So for example, we make some programs and calculate something and make some arrays or some strings or some hashes, Matsuda-san's presentation says, and almost is a thread local. So we don't move, we don't send such an object to the other threads. But sometimes there is sometimes we need to share some information by each thread. So it means that so we can introduce sharing object which requires a synchronization for such only a few shared objects. So such a synchronization introduces some overhead, but if we understands this is a small amount of shared objects, then maybe it is acceptable. And also, we need to track which is a shared object and which is a non-shared thread local object. So this guild idea supports such a separation. So recognition for the shared object and non-shared object. So at first, so normal object, so if we make a string or array or something like that, they are shared object, non-shared object. So you can't send each, you can't share such a normal object between guilds. So it means that if these objects, these three objects are created at the guild 1, then guild 2 can not access these three objects. So we say it is so these three objects are member of guild 1. And we define they shared objects. So immutable object and class module object and special mutable object and isolated proc. So I show you more details about them. So shared object is shared mutable object is problem. So we can share immutable objects. So immutable object, so it is very straightforward idea. So immutable object is not a frozen object. Frozen object is Ruby's feature which we cannot modify after that. But for example, array A1 is frozen object, frozen array, and contains a 1, 2, 3. 1, 2, 3, the numbers are frozen object. So it means that array, this A1 object point to the all of them are immutable object. So the array 1 is A1 is immutable. But A2 has a mutable object. A2 point to a mutable object. This object is immutable, then it is not immutable. So we need to suppose some kind of deep freeze or something like that feature by syntax or runtime method or something like that. So fortunately, numeric object or symbol object or something string, some kind of strings are immutable. So we can think they are immutable objects. Also, so with guilds, class and module objects are shared objects, shareable object, we say. And so the good point is if we share the class or module objects, it is easy to program. But they have some mutable objects, so we need to introduce some protocol to change these attributes, some kind attributes such as constant values or class variables or instance variables for such a class or module objects. For example, so this example shows class C, the constants const point to the mutable object. So if we allow such a code, then, so we can share such a mutable array between guilds. So we need to profit such a case. And we will introduce some special mutable objects like software transaction memory or something like that. So it's called maybe concurrent data structure or something like that. And they require a special process for synchronize. So it means that we need to begin the transaction for such a concurrent data structures. So using this idea, so we can understand they are concurrent, so shared objects. So we need to track only for them, only them. So compare with normal array or hash or some container objects. So they require some special synchronization protocol and overhead. But maybe such synchronization data, shared special data objects are not so many. So I think there are no problem with that. And we need to introduce some kind of isolated proc. So normal proc can point mutable objects. So for example, this line code, so local variable A point to the outer variable, outer variable, and this variable point to the mutable array. So it means if we share these proc objects, then some mutable shared objects can be shared by guilds. So we need to prohibit such a case. So to prohibit such a case, so we introduce an isolate method for the proc class. So this means that so if we try to access to local variable A, so such a proc object, we can't isolate, and it raises runtime error. There are many details, but I skip this on this presentation. So I show the guild creation example before, and this past block will be isolated. So if we access to the outer variable, so in this case G1, so the outer variable from block, then so this code should raise runtime error. Also, so there are shared object and non-shared object. Shareable object and non-shareable object. And we are discussing about how to define the communication API. So we introduced some send receive semantics, and just now we define address is the address of sending or receiving is the guild itself, like Alan and or Elixir processes. So sending shareable objects means sending only reference. So there are no overhead. But we need to, so if we want to send mutable data, normal mutable data, then we have two semantics, copy and move. So this is a very simple example. So make a G1 guild. So G1 guilds receive some value from other guild, and receiving this new number and run some task. So this case, it's called Fibonacci function, and it returns send back to the parent guild. And this case, so sends 13 to the guild 1, and this running this code, and after that, we can receive the correct answer from the Fibonacci guild. So sending shareable objects, then we can only send the reference. So it's very lightweight. If we need to send non-shareable objects, we need to. So option 1 is copy everything. So if we want to copy the object 1 to from guild 1 to guild 2, then we need to copy everything the O1 reference to. Or we prepare another option. So moving So moving means that so if we want to move these O1 objects, then invalidates the access from O2, guild 2, guild 1. So after moving, if we access to the O1 or something, some object reference from O1, then it is very prohibited. But guild 2 can can access to the O1. So maybe it means transferring the membership. So there are several. So sometimes it's such a there are such several use cases to use move. So if we don't access send object after sending them, we can send them fast. So we don't need to copy everything, so it will be very fast. So if we want to exchange the huge string data, we don't need to touch. We don't need to copy everything. Okay. I want to show some patterns, so master worker pattern and pipeline patterns. So this case, so this is a Fibonacci. So making several Fibonacci guilds and sends a request. So send a number, then it returns the calculated Fibonacci number to the main guild. This program works fine just now, and also we can make some pipeline patterns. So so please see this code. So this code make strip, uppercase, and replace. So passing this string, then the answer will be this one. So this task has 3 independent tasks. So of course, on Elixir, we can write such a code. So we can make several guilds to calculate such 3 tasks. So this is very complicated. But if we introduce some framework for the frequent patterns, so we can. So this is my trial to make a pipeline definition of pipeline guilds pattern, and using this method, we can make such 3 guilds by this method. This framework method. Maybe this is a very preliminary trial, and we will we need more discussion about that. So checking the performance. We use 40 core machine to evaluate. So there is 14 cores using, we can see the top command. And there, compare with the serial execution, then we can see the performance multiply. But it's bound to the 15. So this is live. So, but there are no time. Okay, there are no time. So skip the demo. And also the guild is so Fibonacci example we can do with process forking. So I try to compare with the process forking. Then there are no performance benefit using this on this same machine. So it is maybe some not surprising data. So if we make more and more the complicated example, then we can see some difference. And also we can reduce the memory consumption because we don't need to we don't make more Unix processes. Okay, so there are more and more details we need to discuss more and more. So we can, I can't introduce everything, but we will continue the discussion. So there are the good point and bad point with process goes thread, out fiber or fiber. So the similar concurrent features, and there are several pros and cons. So we need to understand what is your best feature to make a concurrent program. So today I chose these topics. So thank you so much. Maybe one or two questions.
Do you have any questions from the audience?
Question for garbage collection.
Okay.
Hold on a sec.
Garbage collection in guilds, are they separated or are they collected together? Maybe is there global garbage collection? How does it work roughly?
So just now, I don't implement garbage collection for the guild. So we need to disable the garbage collection to measure this preliminary implementation. And so in future, we make not separated object heap. So because we need to share some kind of shareable objects. So, but we can run, maybe we can run marking phase, garbage collection in parallel. So not separated, but run in parallel. So is it okay to?
Yeah, that was a question. I think that's similar like the Java VM doing like
a
global heap space.
So Java introduced more and more sophisticated garbage collection to run in parallel or concurrent garbage collection, but we don't support such a the very sophisticated one because we need to support the C extensions. C extensions means so there are many source code we can't access. So if we can rewrite everything, every C code, then we can hire such a thing, but we can't access to the current existing C extension, so we can't do such a great garbage collection. So maybe we will make we will make effort to improve the performance of garbage collection. What we can do on such a restriction.
Thank you.
Any more questions? We have one last question. No? Do you have anything that you would like to add?
I can show you some demonstration on the 40 core machine. So if you want to see, so please ask me later.